This is my arc length project for AP Calculus AB. So first, to find my path, I took a number of steps. The first of which, I had to identify what area of my town I would use for my path, which eventually I found. Then, using the Draw a Line tool on Google Maps, I was able to trace out the path that I used to walk in my town, which ends up being a polygon. Using the image on the right, we can see that it is nearly a rectangle, except for the right half of the image, which includes an arc, as well as a non-90-degree angle. Using the zoomed-in image, we can see the near quadratic section referenced earlier near the bottom of the path. Regarding the quadratic section specifically, I set my origin to the leftmost part of the arc. This will be relevant for future calculations. To find the points of the arc, I took a screenshot of the quadratic portion of the path and then aligned it such that the leftmost point on the Google Maps path was at the origin, as seen in the picture below. The next step was to then relay all of the information on the points along the path on Google Maps to a graphing calculator like Desmos. By cross-checking both the image and Google Maps, I was able to approximate the point on Desmos for each point on the Google Maps path. Then, by putting this information into a table, I would then later be able to use the Desmos regression calculator to find an approximate equation for the arc. This arc was found using the Desmos regression calculator, specifically by using the Desmos quadratic regression calculator. I was able to get an exact formula that closely approximated the arc. Using the formula, the integral from a to b of the square root of 1 plus the square of the derivative of the equation with respect to x, we can find the exact length of this arc. In this formula, a is the initial x value and b is the final x value. Knowing the initial x value is 0 and the final x value is 6.4, we know that we integrate from 0 to 6.4. From the fact that the Desmos quadratic regression calculator gave an equation of 0.140987x squared minus 0.3535547x plus 0.1490979, we can find that the derivative will be 0.281974x minus 0.353547. Then, finding the square of this derivative yields the following equation at the top, and then adding 1 to this yields the equation right below. Plugging all of this information into the formula, we get the following definite integral, which we can solve using a calculator. Evaluating the integral yields an arc length of 7.885041. However, this is not the length of the arc in feet, but rather in the units of the Desmos calculator. To correct for the scale differences, we have to find the domain of the quadratic function, assuming that the origin is still at the leftmost part of the arc. Using the measure tool on Google Earth and a line placed parallel to the y-axis, we can find the domain in feet for the arc. The domain in real life is 91 feet, meaning that the scale factor from real life to Desmos is 91 to 6.4. This means that to find the arc length of an integral in feet, we have to multiply our integral by 91 over 6.4, which yields a final arc length of 112.115421. Knowing the length of the arc, we can find the rest of the path length, which involves only straight lines. Because it involves only straight lines, there is no need to create another coordinate system, as the pre-existing measure tool on Google Maps can tell us the distance for each straight line. To find the distances, I used the measure tool from one distance to another, and as we see in the following images of this slide and the following one, I was able to get the distances for all of the non-arced components of my path. And this is the final image of my path that does not contain any arcs. And now we can sum up all of the previous distances from the screenshots, showing us the process of finding the distances. The first section was 660 feet, the second 268, the third 92, the fourth 792, and the last 343. Adding these together yields a non-arced path length of 2,155 feet, but taking into account the length of the arc, we get a final length for the entire path of 2,267.115 feet approximately. To find how accurate we were, we can reference the true path, which gives us an exact measurement of the path. The distance is 0.432 miles, which translates to 2,280.96 feet according to Google Maps. By comparing the two distances, one calculated on our own and the other given from Google Maps, we can see that the two are very similar to each other. Going further, using the percent error formula shown on the slide, we can see that we get a percent error of 0.607%, further indicating a very accurate calculation. Thank you for listening.